Right. Here's a beginning to chapter 4, which is going to be closely related to chapter 3, and that we're still going to be looking at linear equations. The difference here is instead of just analyzing one linear equation and trying to check out its graph, we're going to check out a system of equations, and that's all the definition is up here. A system of equations is just a set of two or more equations. We'll just stick with two. That we try to solve simultaneously. So I'm going to try to find a solution to this equation and a solution to this equation, right, simultaneously. So that would mean that I need an x and y value that works and that makes the top equation true, and at the same time the same x and y will make the bottom equation true. Right? Throughout the course of section 4.1 in the next couple videos, we'll look at three different ways to solve this equation. Right, so the first way is, well, let's take a look at these equations and do what we already know what to do. Right, we know how to graph these. I mean, granted, they're not in y equals mx plus b form, slope-intercept form, but we know how to do that. Well, hopefully at this point we do. So, all right, the first way to solve this problem, so solve, that's probably too high. All right, to solve this, one way is to graph. So we have 2x plus y equals 5. And I'm going to separate them this way. Negative 4x plus y equals negative 1. Alright, so we have both of those equations. I wrote them side by side because we're going to need to manipulate both of them to put them in y equals mx plus b form. Alright, so we've done this plenty of times already. That would mean we need to solve for y, so we can add a negative 2x to both sides here. Alright, remembering that these are not like terms, variable, constant. Alright, these will cancel. We have y equals negative 2x and a positive 5. Now it's converted into our nice form. And we can play the same game over here. Positive 4x. Y is equal to, these are not like terms, so we have a positive 4x and a negative 1. Okay, so now we have both equations of our lines in slope-intercept form, which means we can go to a graph and check out what's going to happen. So I'm going to do this relatively quickly because we already have this skill set. If we're looking at an equation in slope-intercept form, we know the negative 2 is the slope, the 5 is the y-intercept. We need to go up to 5, it looks like. So we got 4, negative 4, 5, negative 5. All right, remember, think of your slope as a rise over run, so in both of these cases, we should look at it as a rise over run. All right, if I'm going to graph this line, y-intercept of 5, and then from there we'll have to take a negative 2 rise, so down 2, 1, 2, and to the right 1. That's our first line. Take that shape. All right, second line. It has a y-intercept of negative 1, so that would start me on the y-axis at negative 1. And I have a rise of 4 and a run of 1, both positive, so that would be up 4, 1, 2, 3, 4. And to the right 1 meets at that point. And there's our two lines. All right, so remember what these lines represent, and we'll answer our own question based off of what we know. All right, this line represents every point on this line is a solution to the equation y equals 4x minus 1. Every point on this line is a solution to y equals negative 2x plus 5. So if we're trying to find a solution to both equations, that would mean it would have to be a point that falls on both of the lines. Well, is there any point that falls on both of the lines? Yeah. There it is. Right where those two lines intersect. All right. Once we have both drawn, we can find the coordinates of that. Looks like it's at x is 1 and y is 3, so this point 1, 3. That is our solution. So what that would mean is if we use this x value and this y value back into our original equations, right, the 2x plus y, or I have them written over here as well, we can do this work. Right, that would mean that if I plug x and y into both equations, it should make them both true. So we can do that really quickly. I'll plug in x and y over here just to double check it. So that'd be 2 times 1 plus 3 is equal to 5. All right, and that'd be 2 plus 3 equals 5. Check. All right, plug it into the bottom equation. Negative 4 times 1 plus 3 equals negative 1. That'd be a negative 4 plus 3 should add up to a negative 1. Check. So this single point is a solution to both of the equations, so that would be why it's our solution to this system of equations. All right, there's no other point that's going to work out for us. All right, it's just exactly where those two lines cross. So this is one way to solve a system of equations, is using our skill set before and graphing these equations. All right, we'll look at 2 other ways to do this, but first, before we end this video, let's see other scenarios that could happen when we graph 2 lines. So if we're going to solve and think about this graphically, possible outcomes. If I'm looking at 2 lines and I want to graph both of those lines, there's actually 3 possible outcomes that could happen. The first one, which we just saw, which is going to happen the most often, is if you just have two non-related lines, they're going to intersect at one single point. You're never going to get more than one intersection with 2 lines that are not the same. They're only ever going to cross at one single point. So we would say we can have this crosses at one point. Okay, so this point would be our solution, whatever the coordinates are there. Option number 2 is these lines they might never cross. We talked about this before. Those lines are parallel, and by definition, parallel lines never cross. So if 2 lines never cross and you graph them, then we'd say there's no solution. Because there's no point that's on this line that is also on this line. Okay, so that's option number 2. And option number 3, which is the strangest of all, would be that, let me do this in a different color. Be that both lines are in fact the same line. You might think that's strange and doesn't happen very often, and you're right, I would have to be very particular about the two lines that I created to make them actually end up being the same. They'd have to have the same slope and the same y-intercept, so you can usually kind of tell that these are happening beforehand, right, if both equations look alike. Right? If this is the case, okay, we would say both lines are the same. And in this case, every single point on the blue line is also a point on the black line. So not only is there a solution, there's actually every single point is a solution on these lines. So there's an infinitely many solutions. Right, so when you're graphing these are the only three options that could happen. Right, but for our example, and for most of the examples we'll look at, they're going to cross at one single point. All right, so in the next video, we'll look at how to solve this in a new way.